So, Hari Om, Pranavji, you can start.
Okay. Um, Welcome everyone to another session of Ascent. So today's talk, the topic is something, nothing, everything, and the number line. So, today what I will talk is I will talk a few aspects of mathematics, specifically like put here the number line, uh, and I will try to interpret it in my own way and relate it to how I see things in spirituality. So that's the whole point of our sessions. How can you relate science to spirituality? And I find a very nice parallel here with the number line. So I'll be talking more about that. But before we dig into what a number line is and all of that, I just want to start with a very basic way of how we understand things. So, so over here, I want to start with language. So, when I say the word language, what comes to your mind? So, it can be um, something that you use to communicate, right? Like, for example, the language that I'm speaking in right now is English. What I speak at home is something different. I can speak in Kannada, and be speaking in Malayalam, so on and so forth. Different languages is what I speak. But what is the basic essence of language? Why do I use language? Why am I using English right now? Well, it is to essentially express what I want to communicate. So I have some ideas in my mind, I have some concepts in my mind, and I want to communicate these things. And so that is why I use language. So language is a medium, essentially, it's a medium to express things. So how do I express things though? So for a concept to happen in my mind, I should think about it, I should question about it. So when I ask why, these concepts begin to form. So, uh, so for example, only when I accumulate new ideas, new concepts, only when I ask why does this happen? Why is there a thing in front of me? And then I understand it's a laptop and so on, right? So concepts are formed through the questions of why, and then it is expressed through languages. For example, it could be, like I said, you could express things in Sanskrit, you could express things in English, and so on, Malayalam, and so on and so forth. So now, what happens is human beings are by default curious beings. So it is not enough for us to just express concepts. What we are also very, very interested in is the relationship between these concepts. Okay. For example, like I said, concepts could be anything like a laptop. Here I have a cone and something called as a DNA. But like I said, what I am interested at is the relationship between things, like how something has happened, how is there a DNA, why how is there an ice cream cone, and then when did DNA begin to form, where exactly in the body can you find DNA, and so on and so forth. So you have some concepts which are expressed through language, but then you're just not stopping there. You're interested in the relationship of how these concepts are interconnected. And that is where the questions of how, when, and where come. And the ideas of these relationships are essentially communicated through science. For example, how does a DNA form? You say you have some protein, it's a protein, and then you say there are some nucleic acids and so on and so forth, and then they form this double helix model, and that's how you say a DNA is there. So behind the concept of DNA, there are so many answers to how a DNA is formed, right? So these relationships are essentially communicated through science, and the language of science is essentially mathematics. So you discuss how a cone is formed through some equations. You describe how a helix is formed through some other set of equations, and so on and so forth and so on and so forth. So essentially, you're trying to quantify some. Anytime you're trying to quantify something, you are using the language of mathematics to explain. So you have questions of why, which forms concepts that are expressed through our conventional languages. But then that is not enough. You have questions of how, when, where, which are questions that need further quantification. And for that, we have science, and the language is mathematics. So this is the idea. So for concepts, the languages are our conventional languages of communication, and for quantifying things, we use mathematics as the language. So how do we understand this better? So here I have a one-to-one correspondence of things. So for example, uh, in a language, we have alphabets. For example, we use A, B, C, D in English, E, so on in Sanskrit or Malayalam, and so on. So we have alphabets uh, in language. So what is the alphabet of mathematics? So it is essentially numbers, 1, 2, 3, 4, and so on. So these numbers essentially form the alphabets. Then, once you have an alphabet, you can form words. So there are different kinds of words you can form. For example, in English, these kinds of words are called parts of speech. So you can have words that make up a noun. You can have words that form a verb. You have words that form an adjective. For example, as an adjective. So in an Indian language, this would be like nama. In Kannada, you would call a noun as a namapada. Verb would be a kriya pada, and adjectives would be guna, and so on. Uh, so once you have alphabets, you can form these words which belong to one of these categories. In the same way, in mathematics, you have numbers. Now, from numbers, you go to different kinds of words you can form. So, for example, these are elementary functions. So you can form different words by addition. So, for example, so addition is an elementary function, subtraction, logarithms, square roots, integration, so on and so forth. So all of these elementary functions are essentially for trying to club a bunch of numbers together, right? So essentially, elementary functions are exactly like your parts of speech. So now let's go back to the language again. So you have alphabets. From alphabets, you can make words. From words, you can make sentences. So, for example, a sentence you would make over there in English is, for example, is my name is Pranav. Now, what is the sentence equivalent in mathematics? It is nothing but equations. So, using the numbers 1 and 2 and combining it with the elementary functions, for example, plus, we can form an equation that says 1 plus 2 is equal to 3. So, and finally, to make sentences, and most importantly, in any language, to make a sentence, there are a set of rules. You have something called as grammar, which you learn. For example, what I have here initially as my name is Pranav is the correct form of grammar. Now, what's a incorrect form of forming a sentence is something, for example, pronoun name my yes. It does not make any sense in the English language. So it doesn't follow the rules of the grammar. So for any for any language, there are the alphabets and then you can make some functions, for example, parts of speech. Then you can club all of these together to make sentences. And there is a set of rules called grammar, which govern the way I construct a sentence. And so in mathematics also, there is an analog to this. What we have as grammar in language is essentially axioms or rules in the mathematical language. So, for example, an incorrect mathematical sentence would be 1 plus 2 is equal to 4 because it doesn't obey the rules of addition. So the axioms or the rules of addition does not permit such kind of a statement. Just like how the rules of grammar does not permit a sentence like pronoun name my is. So as you can see, like there is a very nice one-to-one correlation between what we have as languages in the conventional sense and how mathematics essentially is a language to describe science. So now we have that I have established this connection that mathematics is essentially a language of how science is described. Uh, it's nice to look at where because I had earlier pointed out that language essentially describes why. Language forms concepts. So language describes why, and mathematics describes how. So it's nice to, and since mathematics and language, a conventional language, I have brought it in the same platform. There is a nice commonality between these two. It's nice to see how these two fit in the aspect of how questions are formed. Like, for example, where does why and how fit into the languages, right? So then, if we look at this, this is not yet a number line, but it is an example of a number line of what true subject and true object is. So we have discussed in our previous talks and in different platforms, why is essentially a question pointing to the true subject, and how is a question pointing to the true object. So science essentially is behind objectivity, and Vedanta is behind the subject. So why points to the true subject, and how essentially points to the true object. So if I were to put where Vedanta and mathematics is in this number line, it would be at these two ends. So Vedanta is searching for the true subject, mathematics seems to search for the true object, because mathematics tries to answer how and Vedanta tries to answer why. But if you think about it closely, the true object and the true subject are not really different. So mathematics and Vedanta at some point should go behind the same thing. So they should draw a lot of parallels. It is evident that mathematics should draw inspiration from Vedanta, and likewise the other way, Vedanta should have some qualities of mathematics as well. So, uh, before I begin to how this essentially works and so on, I would like to put two more things into this, what I call as science and religion. So these two are somewhere in between. So science is trying to be objective, but it has some elements of subjects, and religion is trying to be subjective, but it has elements of objectivity. So like I mentioned before, there shouldn't be a fight between mathematics and Vedanta, but there's always going to be a fight between science and religion. So, one of the best examples I like to talk about where mathematics and Vedanta uh, kind of mingled together in one personality is this person Ramanujan. So he makes a very profound statement. He says, an equation means nothing to me unless it expresses a thought of God. So, this is very profound. It means that whatever you see whatever you understand through mathematics is nothing but an expression of some divine nature. So it's essentially pointing to the fact that mathematics and the true subject uh, point to the same thing and can't be separated actually. So I will try my hand in explaining in explaining one concept of mathematics and how I feel it is very, very close to how I perceive concepts in Vedanta as well. So, for example, we have the four Mahavakyas in the language that we know of, which is Sanskrit. And when we try to understand it in a very deep manner, we get some very deep, profound understanding of the true subject. In a similar way, I claim when you try to understand the number line, which is a very elementary concept in mathematics, you gain a very more profound understanding of the true object as well. And so a nice a deep understanding of Vedantic concepts as well. So how does this work? I'm first going to explain what a number line is. This is something that we learn all the way in primary school, where we learn how to, where the first time the teacher explains to us what geometry means, we almost always begin with a number line. But we are never taught, or we never think much about this number line other than how it is used in geometry to draw some things and finally to get some marks in the end. But when I think of a number line now, I feel it's a very deep concept and a very fundamental concept in mathematics. So to begin with, let's see what a number line is. It's nothing but a line, and so it's essentially a line with numbers on it. So you arrange numbers 1, 2, 3, 4. It has an origin, which it has an origin, and essentially you arrange them in a particular way. So, for example, in this number line system, numbers are arranged such that they are in the increasing order. And you consider only the natural numbers, so 1, 2, 3, 4, and so on, and they are arranged in an increasing way. So essentially, number line is a way of representing numbers through an arrangement. I could have a very crazy number line as well, which jumps 1, 3, 2, 5, 2, 4, 1, 3, 2, 4, then 6, 5, so on and so forth. That'd be a very crazy number line, but numbers can be represented that way as well. This is a very simple number line that I'm taking up, just to see uh, how these commonalities in of Vedanta can be perceived through understanding the number line as well. So what I'm trying to do here is to understand something, nothing, and everything as parts of this number line, but also trying to draw a commonality between what I understand of something, nothing, and everything of Vedanta. So let's take the first what I think is the easy one, which is something. So if you look at something, if we look at how something is understood as a concept. In Vedanta specifically, something is essentially nothing but a concept. So what is a concept? It has a name and form, nama and rupa. So anything that we see, anything that we observe through our senses, through our perception, it has a name and it has a form. So this nama and rupa forms a concept, and this is something. So where is something on the number line? Uh, it is essentially the numbers that we have. So for example, something is 1. something is two. I have one apple, I have two bananas, I have three kittens, and so on. So there is there is a name and form for these numbers as well. How does that come up? And how does this relate to a name and form in real life? For example, I'm just going to take a simple example of, let's say, an apple. So as soon as I show you an apple, there are several things that come to our mind which makes it an apple. So there is a name and form. So an apple is round. An apple has the color red. So these different statements, these different concepts together put cohesively act as though it forms the concept of an apple. So as soon as I say it's an apple, that means it has to be red, it has to be round. When I slice it open, there has to be small seeds, and it's supposed to taste in so and so way, and so on and so forth. So how do we understand these? So like I said, language is understanding a concept. So apple is the language. You have understood it's an apple. But how do we understand it's an apple? I used how. So that means we have to describe an apple. A description of apple means we have to use some relationships and so some numbers to understand what an apple is, right? So for example, I say that the shape of an apple is round. So you can describe the shape in a mathematical way through this equation, for example. Then I say, what is the color of an apple? I say the color is red. So that again can be represented in some equations and so on using physics and different techniques. So as soon as I say what an apple is, there is the shape, and then there is the form, which is the rupa, and then there is the name, which is apple, and all of these together form the concept of an apple. And so these concepts nothing are nothing but eventually they can be boiled down to some equations which are essentially again some numbers on the number line. So essentially anything which is a concept can be represented in some mathematical way through the usage of numbers. And so, anything which is a concept is essentially a bunch of numbers that we have. It's just like how you have a computer. In a computer, you see a lot of different things. I'm talking to you, for example, we see so many different things. We watch YouTube and so on and so forth. But if you look at what is happening deeply inside the computer, it's nothing but a bunch of zeros and ones, right? So finally, every concept is essentially boiled down to a set of numbers that we have. Uh, and that is how we try to understand something. It's nothing but a bunch of numbers on this number line that we have. So moving on. So if something has a name and form, that's good. We can represent it as a form of a number. But there is this concept of nothing as well, which is essentially the absence of name and form. So, how do we understand absence of name and form? So, this was a question that has been asked for a very long time, for centuries. In fact, this question didn't even appear for a lot of different civilizations. For example, if you look at a Roman civilization, in school we learn Roman numerals 1, 2, 3, 4, and so on. They don't have a concept of zero. If you look at many civilizations, almost all civilizations didn't have a concept of zero. Very few civilizations, for example, the Mayans, had somewhat of a concept of a zero, but it was not completely true. They didn't understand what it meant because they never knew what absence of something is. When somebody is already dealing with concepts, every time we think of something, we understand, try to understand. We are always in the process of trying to understand something. So we are always in the process of creating concepts in our head. So absence of a concept is never natural for us to understand or to think. because we are always in the process of making more and more concepts in our head. So absence of a name and form, absence of a concept is something that is totally out of the ordinary. It's something that's completely out of the traditional number line that we have. But uh, but there is, it turns out there is a way to kind of represent nothing, and this was actually introduced by Indians. This concept of something called as a zero, or nothing. And it came, the concept of zero essentially came, it was inspired because our Indian philosophy stresses so much on the concept of nothingness. And so this was something very natural for the Indians to understand, whereas many of them failed or in understanding this concept of nothing. So in our number line that we have right now, zero is what we call as the origin. So it is the origin of all these different numbers. So how do we understand that zero is the origin? So a very nice way is, for example, to take this set of things that we have. So for example, a line, if you see, it's an equation described by this, but more importantly, it equates something with zero. So there are only a specific points that satisfy such that it always equates zero. And what are those collection of points? It's essentially this line. Similarly, in this equation, there are only a certain set of numbers that satisfy such that it adds up to zero. And what does that describe? It describes a cone. And so on, you have the arrangement of seeds in a sunflower. And how do those arrangements come from? Because they precisely add up to this one particular number, zero. So every equation that you have is essentially coming such that you understand what zero is. If there is no way for you to compare two things and say it is zero, then there is no way you'll be able to construct any equation in life. Two things are equal only because they add up to zero. So every equation can essentially understood from the origin, which is zero. So like I have written over here, you can write every equation as zero is equal to something, zero is equal to something, zero is equal to something. So every equation in the universe that you can describe, every pattern of numbers that you can have essentially has to amount to nothing. So this is a very profound thing, and understanding that this zero is the origin of all these numbers from the number line is something that is not very it's highly intuitive and very and it has to be understood in a very deep way. And this was something the Indians had. So understanding so in the number, in the case of the number line, nothing is essentially this concept of the zero that we have. So zero is essentially the origin or the originator of all patterns that you can make. So this nicely translates to what the Buddhists have, which is the Shunyavada. Everything that you see, every concept is essentially nothing. Uh, so this is how we can understand zero as the origin of all these numbers, all these patterns, and so on. Uh, but that's not yet complete. So we have something which is the presence of name and form. We have nothing, which is the absence of name and form. In Vedanta, we have everything as well. So what is everything? So in Vedanta, everything is understood as beyond the presence and absence of name and form. So, uh, so this is a very nice challenge. So how do you understand something which is beyond something? So language, like I said, has a very nice way of putting this one out. So the idea of trying to represent something which is not part of something. How do you do this? So language has a very nice way of communicating this. They use paradoxes. So they are statements, but they are true, but they're also not true. So they're contradictory in itself. So for example, in Atmabodha, Shankaracharya says, Vacho yasmat nivartante tadvaktum kena shakyate. So from where or where all speech stops, how can you talk about it? Right? And then there's this other statement which says Anoraniyan Mahato Mahiyan. So it says it's something which is smaller than the smallest and larger than the largest. How can something be both smaller than the smallest and larger than the largest? So these are glitches in glitches in the matrix, so glitches in the language. Paradoxes are essentially glitches in the language which tries to indicate to something that cannot be understood but can be inferred. So it can never be understood but it can still be inferred. So just like these usage of paradoxes. So now how do we infer? So what does this relate to in the number line? So is there something that can be inferred but can never be understood? So mathematicians use this symbol to indicate it. We call it as the infinity symbol. So infinity can never be understood on the number line. If it can be understood, then it is something. So it can never be understood. It is not it is not a number, so it is not a concept. It does not have, so it is not nama and rupa. It is not 1 2 3 4, which is something. It is not zero as well, so it is not absence of name and concept also. It is not absence of numbers also. It is not zero also. It is something which is beyond zero, beyond 1 2 3 4. It can be inferred, but it can never be understood. Infinity is always inferred, but it can never be understood. And that's why physicists hate infinity, because it is a concept essentially that can never be understood. So we are always afraid of infinities in our in our understanding of universe. Whenever an infinity pops up, what that means is there is something that I can work on and try to investigate, which means the theory is incomplete. So physicists hate infinity. Mathematicians love to play with infinity because it can never be understood anyways. So, so infinity is what I feel is the way of trying to understand everything on the number line. Uh, like I said, it can be inferred. So it can be inferred in an infinite number of ways. So, for example, if you look at just the number one itself, it is something, but you can write it as half plus a quarter plus 1/8 plus 1/16 plus so on up to an infinite terms. So there are an infinite terms that make up one. So there is an infinity of term of numbers that can still make up something, but it's infinite. So in a similar way, one can be represented just like how I have 1/2 plus a quarter plus 1/8 and so on. It can be represented in another way. Uh, and there are infinitely different ways of describing a number through infinite terms. So there's infinity popping up everywhere. But what I want to convey is there is this concept of infinity, which is not a number, which is not, it can't be understood. It's not 1 2 3 4. It is also not the absence of numbers. It is not zero, but it forms and so without this infinity, it is impossible to have any of these numbers as well. So this is the gist of how infinity comes up on this number line. It is essentially nowhere because you can't understand it, you can't place it on the number line, but it is also everywhere because every number can be represented through infinity. So I would like to conclude with this shloka that we have essentially sums up the nature of infinity. So we have this Purnamada Purnamidam Purnat Purnamudechyate Purnasya Purnamadaya Purnameva Shishyate. So I have roughly translated it. So from completeness arises completeness. This is the last part. Remove completeness from completeness, and completeness again remains. So if you add something to completeness, you get completeness back. So this is beyond all numbers. If you add 1 to 1, you don't get back 1, you get something like 2. If you subtract 1 from 1, you get 0. But over here you have completeness, which is infinity, and you add infinity and you still get infinity. You take away infinity from infinity and you still get infinity. So this is very profound. And so the first half of the sentence that I have over here is essentially born out of language. The second half of the explanation that I have in terms of infinity is essentially mathematics, but they both point to the same thing. And this is how I feel mathematics and Vedanta have a lot of commonalities, and if we dig deep, we can get a profound understanding of both. Thank you. Questions?
Wonderful, Pranav. You can stop sharing.
Yes.
First of all, very nice analogy between mathematics and language. Mathematics and science. Vedanta and science. Then language and mathematics.
Yes.
So the number line concept mapped to Nama and Rupa, and zero is mapped to, I don't know, what, nothingness. Then infinity is mapped to Brahman.
Yes.
So, very, very wonderful this thing. Incidentally, zero in our ancient times, my father-in-law, when they count zero, okay, they called zero as puja. It is
Yes.
They used to, zero is called worship worthy. Some nothing is the worship worthy. It's called 100. They'll say one puja. 1 2 puja like that they'll say.
Yes.
Okay. So now where is the question of imaginary numbers here?
Imaginary numbers are essentially so imaginary numbers you can again represent on the number system, but in a very different way. So
how is related to Vedanta or language?
Oh, I see. I don't know the connection yet. So imaginary numbers, you can think of them as rotations. So they are rotations on a 2D thing. So they form rotations. Now, how do I put it in this one? I'm not sure how it goes into
Where is
the
the irrational number and Vedanta?
irrational number can be understood as one of these aspects of infinity itself. It is essentially like, for example, pi. So it's an irrational number. It is again some number that can't be understood, but we know it exists. Because it can be described, pi can be described. It can be described in it can be described through equations and so on, but it can't be represented through the conventional numbers that we have 1, 2, 3, 4, and so on.
Right.
But it can be represented in a different way. So, for example, like I said, there are different forms of number line. So, if I made a number line that goes as multiples of pi instead, then 1 can never be represented, because 1 in terms of pi will be a never-ending understanding of pi. It will be an infinite. It will be an infinite representation of pi.
Right.
So I will have to express pi in like, for example, just like how I had written 1 as an infinite representation of fractions as half plus quarter plus 1/8 and so on. So pi is also an infinite representation like that. So if I took a number line system where I represented everything in terms of pi, then 1 would be like pi. I don't have a way of representing 1 in terms of some finite numbers of pi. So I'll have an infinite representation. So any irrational number essentially boils down to that same number like something concept.
Irrational number, is it nothing but human mind?
What do you mean by that?
Because there is a grammatically, I can give you correct. Grammatically correct, meaning wise irrelevant. That is what is called irrational thinking.
Grammatically correct, but
Grammatically correct. A
Okay.
flying horse is grammatically
Yes.
correct,
Yes.
but it doesn't exist.
Okay. Yeah, so in the perspective of a number line, a flying horse can exist if there are some conditions in the physical universe meets it.
Right.
So in the same way, in the world of numbers, let's take 1, 2, 3, 4, so on, which are the numbers that we're familiar. Pi can exist in in a combination in an infinite combination, such in an infinite combination. So to create a flying horse, you need you need like you need like an infinite representation of whatever we have. So I don't. So the rules of a language does not. So the rules of a language does not. It allows for a flying horse.
Okay.
What restricts it is the rules of physics.
Yeah.
So I don't want to get into physics because I'm comparing mathematics and language.
Okay.
If I get into physics, then I'll have to bring religion. So then we can fight.
Okay, wonderful. Thank you, Pranav. Shravan, do you have any questions? Shravan Murugu?
Really wonderful talk, Pranav. And the comparison, in the beginning, I didn't get it, but it's very deep. So it's really one thing that I always wondered is, like Prabhuji said, there is a imaginary number line, which is the other one, the imaginary aspect of the numbers is orthogonal.
Yes.
So you already go to one level of imagination. And I was wondering, is there a third level of
yes,
orthogonal thing for
yes,
numbers?
there is.
And similarly, can we extend that in
Yes.
Vedanta also? Yeah. What is it? Can you please?
It's just different. So in 3 dimensions, it turns out you need four different things. It's called quaternions. So there is a way to extend this. So that is essentially going to dimensionality. So the way you can think about these is, I have a number line. So a number line is essentially giving you one dimensionality.
Yes.
So imaginary numbers are a way to access another dimensions using the same number line.
Correct.
So you want to represent two quantities at the same time. For example, in electricity, for example, we have something that has in phase and out of phase. So there is an in-phase signal and out-of-phase signal. How do you represent both together? You use complex numbers for them. You have one part which takes care of the in-phase, you have another part which takes care of the out-of-phase. So you have a number line which essentially is one-dimensional. It's a one-dimensional representation of numbers. So now you want to take or you want to involve a set of mathematical functions such that you want to take care of two things simultaneously. So you want to have freedom of two different things. So then you expand it and you say, I want to take care of two different dimensionalities. So then you bring in the complex numbers into the picture. Complex numbers are essentially nothing but, in my comparison, I had figures of speech, which was noun, verb, and so on. And I compared it to elementary functions, which are addition, subtraction, and so on. Complex numbers, essentially, the imaginary I part takes care of that essentially.
Good. And what is the parallel of that in Vedanta?
Parallel of that, it's again a set of rules, right? So it's all for part of something. So
Prabhuji?
you can say the number line aspect. This is my take, by the way. The number line aspect is the waking state, and the imaginary aspect is the dream state. So you
Fantastic.
can represent imaginary numbers. You can represent flying horses in the dream.
Yeah,
Where is
fantastic.
where is Turiya?
Yeah, what is Turiya? Zero is the Turiya then. The
No,
intersection of these.
Turiya, according to me, is the infinite, because you can't represent it on the number line at all.
On the number line. Oh, deep sleep is the zero.
So there is deep sleep, which is zero.
Excellent. Very good.
Zero
Excellent.
is the absence. And then we
Excellent.
have Turiya, which is beyond the absence and the presence.
So this is Mandukya Upanishad in mathematics.
Yes.
Fantastic. Very good.
In fact,
Very good.
I got this number line analogy after reading after discussions of the Mandukya Karika.
Fantastic. Very good, Pranav. Prabhuji? Okay. I think Prabhuji is busy. That's very good. So let's close this talk. And
Okay.
Thank you, Pranav. Wonderful talk, wonderful number system talk. Okay, so probably Mandukya Upanishad you can rewrite in mathematical Mandukya.
Right.
Thank you very much.
Yeah, thanks a lot, Pranav, and Hari Om. Hari Om.
Hari Om.